In this lesson, we're going to talk about linear functions and understanding how they work. So if we look at this equation here, 5x plus y equals 10, this is an example of a linear function. So let's go ahead and plot some points and see why it's a linear function. So I'm going to pick as my x values, I'm going to say here -1, 0, 1, 2, and 3. And what we're going to do is we're going to substitute the x value and solve for y. And whenever you substitute, you want to use parentheses because they help you to avoid making mistakes, especially where negative signs are involved. So the way I'm going to set this up is I'm going to say 5 times whatever number x is plus y equals 10. So now let's go ahead and substitute some of these x values and find y. So if x is -1, we have 5 times -1 is -5 plus y equals 10. And then I need to add 5 to both sides in order to solve for y. And I get y equals 15. So I know that when x is -1, my y value is 15. So when x is 0, 5 times 0 is 0. So we get 0 plus y equals 10. And 0 plus y is just y, so y equals 10. When x is 1, we have 5 times 1 is 5, plus y equals 10. And so this time I have to subtract 5 from both sides, and I get y equals +5. When x is 2, 5 times 2 is 10, plus y equals 10, and when I subtract 10 from both sides, I get y equals 0. And when x is 3, 5 times 3 is 15, plus y equals 10. Subtract 15 from both sides, and I get y equals -5. All right, so let's go ahead and graph these points. I first need to label my coordinate plane. So my x values, I'm going to count by 1. So 0, 1, 2, 3, 4, 5, 6, 7, 8. But my y values do not go up high enough to fit 15. So I'm going to count by 2s. So I'm going to go 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now we can plot these points. So my first point is -1, 15. So that's left 1 and then up 15. So this is 12, this is 14. So 15 is going to be halfway between 14 and 16. So that's going to be about here. Then we have 0, 10, which is going to be right here. Then we have 1, 5. So this is 4, 6. So 5 is halfway between 4 and 6. So about right here. Then we have 2, 0, which will be right here. And then 3, -5. So -2, -4, -5 will be right here. And as you can see, these points line up to form a straight line. So that is why this is called a linear function, because the ordered pairs for each point line up to make a straight line. So this equation, 5x plus y equals 10, is called a linear equation because the x and y values that come from this equation line up to make a straight line when you graph it. And this linear equation has a specific form called standard form. And standard form is this format here, which is ax plus by equals c. So a, b, and c represent numbers. A represents the coefficient of x, which in this case is 5. B represents the coefficient of y, which is 1. And C is the constant. And so any equation that can be written in standard form is a linear equation, which means its graph would be a straight line. Now, the rule here for this is that A and B cannot both be 0 at the same time. If A is 0, B must be some other number. Or if B is 0, A must be some other number. So for example, if A were 0, it might look like this. 0x plus, let's say, 4y equals negative 10. Well, this is okay. Now, normally it won't look this way because 0 times anything equals 0, and 0 plus 4y would just be 4y. So this equation would be written like this. And so now this equation here, even though it looks like it's missing a piece, this equation is in standard form. This 4 is my b value, and this negative 10 is my c value. And the reason why we don't see x is because a is 0. But this is still in standard form. On the other hand, if I write, for example, negative 2x plus 0y equals 14, well, again, 0 plus y, that would equal 0, and negative 2x plus 0 is just negative 2x. So I now have the equation negative 2x equals 14, and this equation is also in standard form, because the reason why I don't see y is because my b value is 0, but my a value is negative 2, and my c value is 14. So this is also an equation in standard form. So both of these, 4y equals negative 10 and negative 2x equals 14, they're still in standard form, which means the graph of either one of these equations would form a straight line on a coordinate plane. So all three of these examples here are linear equations written in standard form. Here, negative 2x plus 5y equals 6. My a value is negative 2. My b value is 5. And my c value is 6. In this second example, x equals negative 2. My a value is 1. My b value, see, there's no y, so my b value is 0. And my c value is negative 2. And in negative 2y equals 7, my a value is now 0. That's why you don't see an x. My b value is negative 2. And my c value is 7. So all three of these are linear equations written in standard form. So let me show you some examples here of equations that are not linear equations. So this first equation here, 2x squared plus 3y equals 10, it looks like it is in standard form, except the problem is that in standard form, you cannot have any exponents on your variables x or y other than the exponent of 1. So this exponent of 2 on this x here makes this not linear. And in this second example here, we have x over 5 plus 10 over y equals 4. Here, this x over 5, this is okay. You can have your variable x or y can be the numerator of a fraction, but your variable x or y cannot be the denominator of a fraction. So the fact that y is the denominator of this fraction here means that this equation is also not linear. All right, so let's go ahead and work through this example here. So here we have negative 4x plus y equals 11, and here's the table of values that we're going to use. So remember, we're going to substitute our x value and solve for y, and you always want to use parentheses. So I'm going to say negative 4, my parentheses for x, plus y equals 11. And now I'm going to go ahead and plug in these values. So first, where x is negative 4, I have here negative 4 times negative 4, that's positive 16, plus y equals 11. Then I'm going to subtract 16 from both sides. And I get y equals negative 5. Next, where x is negative 2, negative 4 times negative 2, that's positive 8, plus y equals 11. Then when I subtract 8 from both sides, I get y equals 3. Where x is 0, negative 4 times 0 is 0. 0 plus y equals 11, so y equals 11. Where x is 2, negative 4 times 2 is negative 8, plus y equals 11. Add 8 to both sides, and we have y equals 19. And finally, where x is 4, negative 4 times positive 4 is negative 16, plus y equals 11. And when I add 16 to both sides, I get y equals 27. All right, so let's go ahead and graph these points. Notice that this coordinate plane is counting by ones for the x value, 0, 1, 2, 3, 4, and counting by tens for the y value. So it could be a little tricky to try to estimate where certain numbers are. So let's go ahead and do our best here. So first point, negative 4 comma negative 5. That's going to be left 4 and down 5. So if this is negative 10, then negative 5 is going to be halfway between 0 and negative 10. So about here. Negative 2 comma positive 3, so that's left 2 up 3. So 3 is going to be about here because this is supposed to be 10. All right. 0 comma 11, 11 is going to be just above 10. 2 comma 19, 19 is going to be just below 20. And 4 comma 27, again, if this is 20 and this is 30, then 27 is a little bit more than halfway. So let's put it about here. And let's see how we did. We're going to grab a straight edge and we're going to draw our straight line. Again, that's pretty close there. Remember, when you're doing this on paper and pencil, you need to use a straight edge. So you get a ruler or the edge of a notebook, or you take a sheet of paper and fold it twice, but you need to draw a straight line. All right, so let's go ahead and take a look at a real world problem. It says here, Hans opens a new video game store and pays the gaming companies $5 for each video game he buys from them. The amount Hans pays is given by f of x equals 5x, where x is the number of video games purchased. So let's go ahead and figure out the different money amounts that Hans may have to pay the gaming companies. So remember that f of x and y are the same thing, right? So I can write f of x equals 5x, or I can write y equals 5x, because f of x and y both represent the output. And we can make a simple table here. X comma y. And this is a simple function, right? Because he's paying $5 for each game he buys. So we can very easily populate these points. If he doesn't buy any games, then he doesn't pay any money, right? If he buys one game, well, 5 times 1 is 5. He owes $5. If he buys 2 games, he owes $10. If he buys 3 games, he owes $15. 4 games, $20. And 5 games, $25. Now let's go ahead and plot these points. So if he buys 0 games, he owes $0. 1 game, $5. 2 games, $10. 3 games, $15. 4 games, $20. And 5 games, $25. So if you remember, there are 2 types of data. There's continuous data and discrete data. Remember, continuous data is where everything connects. We draw lines through that. Discrete data is where the numbers do not connect. You jump from one number to the other. So this here is an example of discrete data, because he's either going to pay 0 or 5 or 10 or 15 or 20 or 25. He's not going to pay in this situation $22. He's either going to pay $20 or $25. So when you have discrete data, you line up the points, but we do not draw a line through the points. So let's go ahead and list our domain and range. Since this is discrete data, we have to just list the points. So our domain, our x values are going to be 0, 1, 2, 3, 4, and 5. And our range, our y values, 0, 5, 10, 15, 20, and 25.